In this video, we're going to discuss two important concepts in probability: the concept of mutually exclusive events, and then the addition rule for probability, which lets us determine the probability that event A or event B will occur. So let's talk about mutually exclusive events first. So two events are mutually exclusive if the occurrence of one event precludes the occurrence of the other event. So some examples. Let event A be the event that the 2020 Houston Texans win the Super Bowl. Let event B be the event that the Cleveland Browns win the 2020 Super Bowl. These are mutually exclusive because if the Texans win, the Browns can't win. And if the Browns win, the Texans can't win. Now, neither of them will probably win, but that's a different story. Now, here are two events that are not mutually exclusive. Let event A be the event that the Dow Jones Index goes up at least 20% in 2020. And event B, the event that Microsoft stock goes up at least 15% in 2020. Now, those can both happen. The Dow could do really well in 2020, and probably that would mean Microsoft would also do pretty well. So these are certainly not mutually exclusive. So let's do some more examples to cement your understanding of this concept. So here we have 12 points in the sample space here. We've got 4 rows and 3 columns. Assume each point has the same probability, which would mean 1/12. So let event A be the X's here. That has a chance 3/12. Event B are the orange ones. That has probability 3/12 because there's 3 orange cells. And then event C is the blue. That's got probably 2/12 because 2 of those cells are blue. Now, which of these pairs of events are mutually exclusive and which are not? Well, A and B are not mutually exclusive. Why? Because if you look at the X and the oranges, they overlap right here. Okay, they could both occur. Now, A and C are mutually exclusive. Why? The X's and the blues don't overlap. B and C are mutually exclusive. Why? Because the orange and blue don't overlap. Okay, so now we can see how mutually exclusive this concept ties into the addition rule, getting the probability of A or B. So for any two events, A or B, how do you get the probability of A or B? Well, you take the probability of A plus the probability of B, but you have to subtract off the probability they both happen, which is called the intersection, or else you'll double count things. Okay, now if you have mutually exclusive events, then probability of A and B is 0 because there's no intersection. So in that case, if X and Y are mutually exclusive, the probability of X or Y is the probability of X plus the probability of Y. So again, some examples. Okay, what's the probability of A or B with our definitions up here? Well, again, A and B are not mutually exclusive. So you take the probability of A, which we know is 3/12, the probability of B, which we know is 3/12, but you got to subtract off the probability of A and B. So that's where there's an orange X, and that's 1/12. So your answer there would be 5/12. In other words, what's the chance that something would be an X or an orange? Well, you got to basically not double count this X right here, which is orange. Okay, now what's the probability of A or C? Now those are mutually exclusive. So A and C can't occur together, so that last term drops out. So the probability of A or C would be the probability of A, which is 3/12, plus the probability of C, which is 2/12. Okay, two more practical examples. If you throw 2 dice, what's the chance you get at least 1 4? So here's the sample space. Okay, this is what you throw in the first die. This is what you throw in the second die. So the first die being a 4 is this row right here, and the second die being a 4 is this column right here. And basically getting a 4 on both is where the X is. Okay, so it's probably getting a 4 on the first die or a 4 on the second die. That's the chance of getting at least 1 4. So you add up the chance that you get a 4 on the first die, which is 6/36, this row right here. Add on the chance that you get a 4 on the second die, that's 6/36. And then subtract off the intersection, the probability you get a 4 on both die, which is this X here, 1/36. And so you get a final probability of at least 1 4 being 11/36. Note, if you hadn't subtracted off the 1/36, you would have got 12/36, which would be incorrect. Okay, now one final example here. Suppose you let event A be the event that it rains on Saturday, and event B be the event that it rains on Sunday. And let's suppose there's a 50% chance of rain on Saturday and a 50% chance of rain on Sunday. Is it sure to rain on the weekend? Now, most people say yes, because 50% plus 50% is 100%. Well, that's not correct. What's the probability it rains on the weekend? It's probably it rains on Saturday or rains on Sunday. That's the probability of rain on Saturday, PA, plus probability of B, which is 50%. Each of these is 50%, minus the chance it rains on both Saturday and Sunday. So you got 0.5 plus 0.5 minus something that's positive, because it could rain on both Saturday and Sunday. So basically this will be less than 1 because you have 1 minus something, which will be less than 1. So it's not sure to rain on the weekend, although if you live in Seattle, you probably think it is sure to rain on the weekend. So in our next video, we'll pick up with the study of independent events.